Hi, so today we'll discuss about another project that I implemented as part of my course in cloud computing. And this project is all about implementing a REST application using Scala and also deploying it in AWS as a microservice. So this application was built using Akka HTTP, which is a low-lying HTTP framework and allows you to make HTTP requests as part of this REST API. You can read more about Akka HTTP over the internet. There are multiple documentations around it. So in this video, the flow will be like first we'll discuss about the project implementation. How did we implement the project? What are the main components? Then we'll move on to the deployment part in AWS. And meanwhile, the deployment takes place. We'll discuss on how to play the game. So let's start with the uh, brief overview of this project. Now, this project contains, as we talked about, Akka HTTP model, where you have the actor and the model. So uh, the game itself is about playing a policeman and thief game where you have a network implemented by a graph, and policeman and thief are two actors which are placed in those graph nodes. And the job of policeman is to catch hold of the uh, thief, and by that I mean is basically reach the node where the thief is moving to. And on the other hand, the thief will need to access a valuable node. So there's a property called valuable data, which is set to true for some of the nodes. So if the thief accesses a node which is valuable, he wins. And if the policeman accesses the node that thief is on, the policeman will win. So this is a basic overview of the game. And now how this was implemented using Akka. So let's talk about that first. Now, the main components of this project are mentioned in the README file. I'll quickly go through them in the code base. So, the code resides in source main Scala, and you have multiple packages. So, the first package is the actor itself. Now, here you have two actors. One is policeman, and the other actor is thief, which are basically our players as well. So, you have bunch of messages that can be passed across the actors as well as the actor system, which is the server. So you have move, you have get allowed position, get allowed moves, and the get position. So these are some of the messages that these actors are implementing, and similar implementation is done for the thief actor as well. So here, this is nothing much, but you have the different messages that can be sent to these actors. So you have the implementation like move. You can move the actor thief or the actor policeman. You can have the get allowed moves for the particular actor to be called, and also you can check the position of the those actors. So this is the implementation of the actor part. Then you move on to the model. So model is nothing. It's just uh, the data, the graph which we have loaded. So this graph is loaded as in the application and it's available to the rest of the code. So the actors uh, access these graphs in order to move and see the adjacent nodes as well. So now comes the server part. So this is the critical part. So our main execution is handled by the server. The start of the execution happens at game app, which opens a port at port 8080 in this case, and your HTTP methods will be calling this URL or this connection string. Now, the game app simply opens the port and provides it to the game server. So game server has all the routes. So the HTTP methods, the headers, and the URL that you will be hitting all are defined in this. So the first route is in itself is the game start. So unless you and until you don't hit this route, you won't be able to start the game or play any other game. And any other you can't hit any other HTTP calls. So you need to start with game start, and then you have bunch of other moves and other HTTP calls that you can make to play the game. Now, before actually playing the game, let's uh, go to the deployment part and how do we deploy it in AWS. So we already have a Docker file created. Um, Now, in order to deploy to AWS, we will be using two services. One is ECS, which is the Elastic Container Service, and it's a Elastic Cluster Service, and one is the ECR, which is the Elastic Container Registry. So these two services will be used. And how do we use that? So first, we will deploy our application as a Docker image in the ECR. So as you can see on the screen, this is the Docker file, and let's quickly go through it. So we'll use Java 11 version. Then work directory, we'll set it. You can set it as per your convenience. I've set it to user source app, which will be accessible inside the Docker. Then you have to copy the jar of your project to the work directory, and also the graph files, the JSON files which contains the data of the graphs. So I have a bunch of graphs defined in inputs folder, and I moved it to the Docker work directory as well. So, and the next part is the environment variables. Now it's up to you if you want to define this in a Docker file or as a parameter. I'll prefer as a parameter, but just for the convenience and ease of readability, I am defining this as a environment variable inside the Docker file itself. Now, the next part is the expose, which is just exposing the port that you want the Docker container to run on. So in this case, we are exposing the port 8080 there. Now, entry point. So this shows the command that you want to execute. Like you want to uh, uh, execute the jar that you are uh, uploading it in the Docker workspace. So yeah, that was all about the Docker file. Now let's move on to the AWS side. I'll open my AWS console. It is already open. So I'll move on to the AWS services. Let's start with the ECR. Now, Elastic Container Registry. I already have some bunch of repositories. Now, a repository is nothing but a collection of the Docker images. So let me create a new repository called game Akka tutorial. And so this is important, like which operating system that you want to run on. And in my case, it's ARM64 because I'm using a MacBook chip. So otherwise, you can choose the operating systems in which you have built the Docker image itself. So since my Docker image will be built in a MacBook chip, I am choosing ARM64. I'll create the repository and it's done. So basically, it's nothing. Just create a repository, and there's an option of view the push commands. So in view push commands, you can see there are 4 steps that we need to execute in order to push our Docker image to the Amazon ECR. So you just need to copy these commands and execute it in the terminal. So I'll do that. The first command is actually to check to log in to the ECR, and it says login succeeded. So that's good. Let's move on to the next part, which is the Docker build. So let's build our Docker image. It will pick the Docker file. Right, so our Docker image is built. Let's tag our image. So it's important that to tag the image so that you keep track of the changes that you made to the images. And at last, you just push the image to the Amazon ECR. Now, this will take around 10 to 15 minutes. Until this runs, let's see how we can play this game. Right, so I open a new terminal. I just click on SBT to open the SBT shell and execute the run command. Now, when you execute the run command here, you can see that the server is online. It's localhost with port 8080. So there are multiple ways right now that you can play the game with. I'll start off with playing this game from Postman. Postman, let's open Postman and see how we can play the game. So as I mentioned earlier, we need to start off with executing the start command, and let's do a post, and let's click on send. So as you can see, the send command was succeeded, and we already got a message that states that the game has started. Policeman is at node 1 and thief is at node 6. Now, for the demo purpose, I'm using a graph which is of 20 nodes, quite small, so that I can walk through all the cases that happens in this game. Right. So now the next command that we will like to see is actually to check the allowed moves. So what I mean by allowed moves is basically the moves, the nodes on which the policeman or the um, thief can go. So let's check that. And so it's a get request that we need to make. We need to mention the actor or the player and also the method. So it says allowed moves, and you get the moves uh, that the thief can go to. Now, the important thing to note here is the scores part. So this game has a scores concept because you are actually moving on a node on a graph, which is the original graph, but there's also another graph which is a perturbed graph, and that is basically used when you hit this allowed moves option. So perturbed graphs has some cases where some of the nodes or edges are modified. So it might be a case where you did some of the moves in the allowed moves section, which is not there in the original graph. In order to gauge whether to move to that node or not, we have this force concept. It's nothing but what is your card index. It checks the outgoing edges and takes a sum of that. And if like the node is matched to the original node, it will give you a score of 100. And if it is not, then it will automatically decrease the score according to the number of matches. Right. So now, as you can see, Thief right now has um, two options, and both of which have the valuable data set to true. So if I move the three to move to two, let's see what happens. This will be a post request, and uh, so it says that invalid move node is not adjacent. So that means the node that we moved to was not there. So let's go back and see the allowed moves. So as you can see, like so we hit a node which was not adjacent. So a thief can't move to any random node in the graph. So it has to move to a distant node, which is 1 and 14 in this case. So let's again go to the move thief and select 1 this time. Right. So here you can see that you move to a node where the policeman was. The thief moved to a node where the policeman was, and uh, policeman and basically policeman wins in this case. So um, this is how you can play the game using a postman, and similarly you can hit the curl commands as well. So right now let's restart the game again, uh, and see some another edge cases using this curl command. Right? Okay, so now the first step is actually to hit a post request to the our local URL, which is localhost on port 8080, and game will be started. So now the policeman is at node 20 and the thief is at node 4. Now again, let's go and see the allowed moves. Uh, thief, this would be a get request. Oh, I think it's the game part here, which needs to be added. Right, so uh, again, you can see the allowed moves for thief. Both of them are uh, having the valuable data set to true. So let's check policeman. Uh, I think let me check whether the boxes have come out. Okay, yeah, I think I'm using the wrong route. We check the exact. Okay, it will not be this. Yeah. So as you can see that policeman has bunch of moves that he can make, and um, you also have those Jacquard index, the scores. And let's try to move the policeman in this case. Let's move 19. 19, it will be again a post request. Yeah, so thief has sorry, policeman has moved to node 19 and thief is at node 4 and the game is still in progress. So this is the status. Let's check the policeman moves again. Um, and let's go to 11 this time. And I'm basically wanting to go to a node which is not there in the original graph. So let's try to do that. Let's see the allowed moves. It's 12, let's take it 12. And 15. Yeah. So 22 is one node which doesn't exist in the original graph, but however it is there in the perturbed graph. So this means that if the policeman goes to node 22, he should lose because it's an invalid move. And here you go. So it's an invalid move. It does not exist in the original graph. So, and again, we'll turn the status as thief winning the game. Right. So let's see. Yeah, so our Docker image is now pushed. Let's go to AWS console. Go to the graph VDK. It was graph Akka tutorial, which has our image. Now our work is done in the ECR. Let's go to Elastic Container Service and create a cluster. So creating a cluster is very simple. You just give a cluster name. Again, let's give the same name. So in this case, we'll be using AWS Fargate, simply because it's not a large application and it's easy for demonstration purpose and purposes, which is not basically a business use case. And it's cheaper as compared to the EC2 instances. So it's better that if you want to test something or demonstrate, it's better to use a AWS Fargate. So I'll check AWS Fargate and just click on create. Yeah. So this will take around 1 minute or so, and we should be done with creating a cluster. Yeah. So our cluster is getting created, and let's move on to creating a new task definition, which is nothing but a task that you will like to run on the cluster itself. So give a name to this task, which is Akka like uh, the machine as ARM64 that we selected earlier. We can reduce the memory to 1 GB and CPU to 0.25 because it's not a heavy application. Now, the image URL you need to copy from the ECR. So this is the image that we deployed. And you copy the URL and add it here. You can give a name to this uh, container. And this is the important part where we want to expose the port number 8080 that we decided for, that we configured for the Docker image as well. So our server is also running on port 8080. We need to match that port. So select the memory as one. And rest you can leave it options open and click on create. Yeah. So your task is now created. Let's see the cluster. The cluster is there as well. Yeah. So now you just need to add this task to this cluster. You can do that by simply adding it as a task or a service. I prefer as a service because it allows you to configure multiple tasks and also provides you an option of having the service discovery configured for your task. So let's go to the configuration details. I'll select the launch type method, which is a Fargate, and application type is service. Select the family. So in our case, it's Akka tutorial game. Revision 1, we only have one update to our Docker image, so it's the latest patch. Service name, let's give it service name to this, which is will be, yeah. So currently we only did one task. We don't need any sort of load balancing or parallel computing right now. The important part, however, is to configure the security group correctly. So we need to select a security group which allows the traffic through the particular port. Now, I already created a security group, but let's see the inbound rules once. And uh, you can create this security group at your end just by looking into the inbound rules. So let's go to the security group. And these two are the inbound rules. So IPv4 and IPv6, both the IP versions, we have opened the port 8080 from any of the sources. So you need to make sure that the security groups have this configured, right? So this you can keep it as default. So my VPC is default, subnets that were created earlier. I'm using those and click on create. Yeah, so now my service is getting deployed. So in a minute or two, we can see the logs for the service and also the endpoint which it will expose. We can see that now our service is running in the cluster. So let's see the logs, what it says. Let's click on the service. So each service we configured for this service we configured one task. Let's look at the task for the logs. And these are the logs. And here you can see that this port will likely be 8080 on which it is listening to. It should be there. Yeah. So the server is online at port 8080. Tried hitting the URL. So let's see what happens. So how we will hit this URL. So in Fargate, what happens is that each task is assigned a public IP, which is accessible from the internet, from everywhere. And since the security group allows that traffic, we should be able to hit this IP. Now let's try to hit it from a URL. Let's go with IP and put 8080. Yeah. So the request goes through. However, since this is not a valid uh, request, we need to first make a post request to this URL and then uh, see whether the status, the allowed moves are available or not. So let's go to Postman again. Instead of localhost, I'll just copy this URL or public IP and start the game. So see what happens. So we can see that the request made it way through and it took some time, but I think it was due to the wrong URL that I was getting. But yeah, so you can see that now the public IP, which can be accessed from anywhere, is now listing over the port 8080, and in the game you can play the game from this URL. So going back, uh, let's see whether we get a request response when hitting the series of the game from the URL from the browser itself. Yeah, so we do get a response where the policeman is at node 13 and the thief is at node 6. So similarly, we can see the allowed moves. Let's try that as well. Yeah, so you can see that now the game is active, listening to this URL deployed in AWS, and we have our first microservice deployed in AWS. Yeah, so that was all that I had for this project. I'll link all the relevant sites which has this information about deploying in AWS, what things you need to take care of, and also the repository which has the code. Thank you.